All right, Master Mason's note. So we're continuing our work on Schrödinger, cat in the box, radioactive isotopes hitting the mechanism that releases the poisonous gas or TNT into the environment. Okay. Check. Chessboard, we're here. This is pawn one, pawn two. This is, figuring out what that is. And so space-time was running a method, and I want to follow suit. I want to make sure we're staying within the same topics, adjusting it to the same time frames in the way I could to them and they could to me. Hopefully an N1 half to what anybody else's horizon, regardless of the Penzrow standard model. Engineer, chemist, they're going to share even mass, zeros and one function. So we're going to need some things like a pursuit algorithm, some Lorenzo. Chasing rabbit calc versus wolves. And we're going to need some 0 and 1. When the population is 0 and the population is 1, everything's kind of harmonious. There's either nothing or there's a specific subset. And we're going to need some things about Occam's razor here and deraccs equation on the electron. We're also going to get into, with those two, deraccs and we could use Schrödinger's or Occam's razor here. Just grab one of them that's handy, and we could talk about technique A to technique B, H, Hubble's constant to T, and wave function. And we're going to begin to start to understand what some of those symbols represent in deraccs equation to determine the negative and positive non-local uncertainty of the electron, having mass or antiparticles like it's supposed to be there, but there's a whole bunch of antiparticles when it's in field doing something that have a small subset, from Big Bang to hot plasmic soup to stone mill. I mean, I can't necessarily use those numbers. They're going to be 0, 1, and then 2 to 1, some kind of ratio off of that. If there's only wolves and 0 rabbits, well, it's not going to be long. 0 rabbits, they might breed, but they don't really have a problem given that ratio of high seasons, low seasons, weather forecasting. Is it really 70 degrees? Well, I need the electron of the son of the drunkard's walk problem here, that one photon, and to decipher all that. Get out of here. So, we do it this, those guys do that over there. Somebody has an individual section inside of here. The entire entropy of tasks. Again, you're going to need to be some level of certified in what wave function calculus of ASE certified. Like, I do the stone bits. Turn them nuts. Get the gear force or mechanical engineering of that type of housing for a gear. This one's a square, and therefore it moves 2 actions, one like this and one like that, or get the machine going here. That's all this action is. They're individual motors that serve to value 1, and in an entirety of that process you can get things like the diversified inconsistency against space and why the space is there. The shadow problem of the sun should be there on gravity, and like, oh, my eyes are open, there's some Maxwell's, there's some light on A, B, C, and D, X, Y, and Z, and the positions of X and Y, the relative nature to each other, groups and patterns that really zero out against anything universally. How many come in here, go to value in time, how many you get in both of them is the wave function. There, I'm looking at it from this horizon, this relative mass, having relative velocities, but if you don't really know them, you're going to have to first do things that break down that grid state. And that's going to be the individual task, clock in, show up, everything. Just be alive, stay alive, inside the limits. So you get that in class and stuff, or how that would even come up in conversation. Filters would determine how you're trying to engineer a way for that to be useful. So, some notes. Catch you on the next one.